Hi, today we're going to talk about limits of accuracy, which is a very important topic nowadays. As you see the questions, they include trigonometry, not only direct questions on limit of accuracy, which is known as bounds. So let's see the example in here. The question says, the diagram shows a triangle of area A centimeter squared, in which A is equal to 5.2 to 1 decimal place, B equals 8.4 to 1 decimal place, A equals 13 to 2 significant figures. A is the area of the triangle, this one, and A centimeter squared. A centi is here. This is the length for this side. B is the length of this side, and we need to find the measure of this angle. Given that the angle marked at C is an acute angle, calculate the lower bound to 3 significant figures of C. So you need to pay attention very well. The first thing is, since the area is given here, the area is given, so what's the formula for finding the area in trigonometry? We know it's half AB sine angle C. So we need to get the value or the lower bound for angle C. You will try to work on making C the subject. So what you will do is, you're going to shift half AB to the other side by division to make sine C the subject. So it will be A divided by half AB gives you sine C in here. And in this case, when you divide by this one, so it can be written as 2A over AB. How we got the 2 in the numerator? As you know, this one, it can be written as multiplication. So it can be written here detailed if you want to know how we got this. It can be multiplied by the half will be 2 and AB will be in the denominator. That's denominator 1. So it can be written instead of AB over 2, it can be flipped. So it will be A times 2 over AB. So now sine C is equal to 2A over A by B. So this is the main formula we'll work on now. We'll try to get the value for sine C, and then we do sine inverse shift sine to get the final answer for the angle C. So let's try our best to get the answer here. The first thing is, let's get the limits or the bounds, upper bound, lower bound for each of the side length and for the area. So here, 1 decimal place, you must be aware of the digits. So the digits here, if you have the decimal point, the first number here is 1 dp, the first decimal place, and then the second is 2 dp, and then the third 3 dp, and here this is the whole number or the units digit. So it will be always mentioned as to the nearest whole number. It's written known as units, and then tens, hundreds, and so on. But regarding the significant figures, it depends on what's the second or what specific significant figure is. So you need to know what's the name. Like here, 13. If you write 13 in here, you're going to find the second significant figure, which is 3, is the units digit. So units digit, you will use 1. If it's tens digit, you will use 10. If it's thousands, hundreds digit, you will use the 100 divided by 2. And this one will be 100 divided by 2. So why do we divide by 2? Because we need to know both the limits. And here the 1 dp or 1 decimal place, it's 0.1. And then you have the 2 decimal places 0.01. And then 3 decimal places 0.001. You need to divide by 2 to get both the bounds. So here you will divide 0.1 divided by 2. It gives 0.05. So A will be between, you need to add 0.05 and subtract 0.05. It will be 5.15 and 5.25. And then if you go to B, you're going to find it's the same thing. Here, 1 decimal place, you will divide 0.1 divided by 2 gives you 0.05. So you can add 0.05 or subtract 0.05. So it will be 8.35 and 8.45. And for sure, you know why there is here equal and here There's no equal. We have equal because this is the number. When we start round up, you're gonna find the answer. If you round to 1 dp, you're gonna find it reaches to 5.2. But here, this is the last number which I cannot reach. Here, if I reach it to 5.25, rounding up will make it 5.3. But here is, I can stop before the 5.25, but it's not our point. The point now, we need to know the limits for the area. The area is 13 to 2 significant figures. What's the second significant figure? It's 3. 3, it's in the units digit, so you can use 1 to be 1 divided by 2. It gives 0.5, so you need to add 0.5 up and down. So, add and subtract, so it will be 12.5 and 13.5. So now you got the limits for each of them. So now you're ready. You can get sine C, but let's know what will we use exactly, which one we'll use here in this question. I'm having 5.15 to 5.25 and so on. You need to know the main operation which we're working on now. Sine C is equal to 2a over a by b. This is the main operation for getting sine C. It's division. Division. To get the lower bound for a division, you need to make the numerator lower and the denominator upper. If you wanna get something, and this is upper. So again, if you have a division and you wanna get the lower bound for something, so you need to decrease the numerator and make the denominator bigger. So when you divide something on many things or many items or into many pieces, so it will be very small, but if you divide something in a few numbers of pieces, it will be big. So here, sine C, it can be having a lower bound by making the numerator lower and the denominator upper. But you need to check something here. We have multiplication in the denominator. So to get upper, you need to make this upper and this upper. Okay. So let's check this point here. I'm going to remove this part, which we used for the formula. And that now we'll need to replace this part in here. So to get sine C will be equal to, replace the area, take the lower bound from the area, it will be 12.5. And for the denominator, we need to get the upper from the multiplication, so we need to get the upper from A, which is 5.25. And here we need to take from B for 8.45. If you multiply them, then you do sine inverse to get the angle. Sine inverse for, here we have 2 by 12.5, can be written as 25 over the product of 5.25 by 8.45. So it gives you, let's check the calculator here. We can do it on the calculator to make sure it gives a proper answer. So it's here 25 over 5.25 multiplied by 8.45, and here, so it will be 34.3, and this is the final answer to 3 significant figures. So it will be 34.0 degrees. This is the measure for angle C as what was required in the question. I wish this was helpful. Let's move to one more idea on bounds, limits of accuracy, to see another question. Hello, now we have another question regarding the limits of accuracy and bounds. Let's see what we'll do in this question. This question was in November 21, and this question is very important. It includes lots of ideas. We have uploaded another video, but now we're going to do a detailed video for you to understand. Here's a triangle XYZ. We have the measure for angle X is 130 degrees, and the measure for angle Y is 25 degrees, and then we have the length for XZ is 16 centimeter. The length XZ and the angles XYZ, YXZ, XYZ are each correct to the significant figures. So everything is given here is in two significant figures. Calculate the upper bound for the side YZ. So let's see the bounds or the limits first. We can get them upper and lower bound for each of these. If I'm having 16 for the side XZ, and this given to two significant figures. So what's the significant figure? The second significant figure is 16. 16 is in the units digit. So you need to add half and subtract half. 16 here, this is the units digit, which is 1 divided by 2 is 0.5. So you need to add 0.5 and subtract 0.5. So whenever it's given to significant figures, you need to check where exactly the specific figure you are working with, and then you check the digits. As I told you before in the previous example, you need to know what digit you're working with to know digits very well, and then you divide by 2. And here we have the angle X, which is 130 degrees. 130 degrees. This angle, it's written in 3 significant figures, but the second significant figure, which is here, if you have 130, and the second significant figure is in the tens digit, so it's 10 divided by 2, it gives you 5, so you need to add 5 and subtract 5, so it's 125 and 135. If you move to angle, sorry, the last angle, which is angle Y is 25 degrees, 2 significant figures, and the second significant figure is 5. 5 is in the units digit. So in the units digit, the same as 16, you're going to add half and subtract half. So the answer will be here, 24.5 and 25.5. Now we need to check very well this part. Now we got the angles here, but whenever you're working with the ratio like sine, cosine, and this, you need to know something very important. But now let's see first, if I want to get a YZ here, you have 2 side lengths are given, 2 side lengths, and you have 2 angle measures are given and 1 side length. So to get YZ, you're going to use sine rule. So it will be YZ. We can call it X small, and this can be called Y lowercase. So it's Y over sine Y is equal to X lowercase over sine X. If we want to get the YZ, so we need to get the X lowercase to get X. So now to get X, which is YZ as what's required in the main question, we'll do cross multiplication. It will be Y by sine X all over sine Y. This is multiplication, by the way. So, but you need to know something very well. Some of you will do what? They will tell me the main operation of this question is division. We have a quantity divided by another quantity. So we will get, if I want to get the upper bound for the YZ or X, I'm going to make this one upper and this one here, I'm going to make it lower. So this upper and this lower. You are correct, but there is something very important you need to know very well. This is upper and this is lower. But there is something, as I said, very important you need to know, which is the sine and cosine, the ratios. So there is something very important regarding the angles when you use the ratio. If now I'm going to show you something related to the sine graph or the cosine. Let's talk now about the sine because this is what's available here. The sine starts from 0, then you have at 90 you have a maximum point, and then 180 at 0 here, and then 270 and -1. You write it here, 270. And then you have 360. And then I will tell you a shortcut if you don't understand the point for this graph using the sine rule, sine graph. And here, this is 270. Let's now work on the first half of the graph. Let's say this is the 180 here, and this is 0, and then we have the 90 and 1. Why I'm working with the first half only of the graph? Because I'm working with acute and obtuse angles here, 25 and 130, so they did not exceed 180 degrees. If you notice here, this is the graph that shows the movement of the angle in here, the angle that's moving. The angle is getting increased till 90 and then getting increased till 180. If you notice, the measure of the angle is getting increased and the value of the sine is getting increased here. For example, this is 30, it gives sine, which is here. For example, 60, it gives something which is here. And then, so whenever the angle is getting closer to 90, the value of sine is being higher or greater. But whenever it's getting away from 90, or that's more like here, for example, 100, it has a sine value which is closer to 1, then 110, it gives a lower value, then 120, it gives a lower value, and then 130, and so on in this part. It's very important. So as I said, now let's make it easier to you here in this part. So let's get it, make it easier to you in this part. Like here, for example, if this is an angle measure here, the reading for its sine is it's away from 1, and then if it gets closer to 90, it gives a reading closer to 1, and then and so on till it becomes at 90 exactly. Sine 90 is the maximum value, which gives 1. Then the angle, whenever it goes further or far from 90, the sine value gets now lower. It gets lower till it reaches till the sine 180 gives you 0. So now this thing is not related just to the bounds. Like you're gonna say, I'm gonna get the upper here. We want to find the upper bound for the whole side length. So I'm gonna make this upper. In multiplication, I make upper, and then here I will make lower. No, the sine is very important. Now, if you're gonna get the upper of sine x, go check the x angle. X angle is obtuse angle, which is 130. 130, it gets far from the 100, from 90, it's closer to the 180. So which one of them you want to take to make the sine x greater or upper bound? Shall you take sine 125 or sine 135? If you take, for example, this is the 130. If you take the sine 135, it means you are getting closer to the 180. So you're taking a lower value. But if you take the sine 125, like here, if you take sine 135, it's closer to the 180. So it gives you a lower value. But if you take sine 125, it gives you what? An upper value. And you need to get an upper value in here. So now in this case, you'll take sine 125. However, you're working on getting the upper bound. Someone will say, maybe you will be deceived by this point in the exam. So you say x is 130, so I'm going to take sine 135. Unfortunately, if you take sine 135, it will not give you the upper bound. Sine 135, it will be closer to the 180, which is incorrect. So you're going to take sine 125. What about this? The 25 degrees. Should I take 25.5 or 24.5? 25 is an acute angle, which is less than 90. So whenever you're less than 90, you need to get closer to the 90. So if you want to get lower bound in here, if you want to get lower bound from y, the least value. So shall you take to 25.5 or 24.5? You'll tell me 25.5 is closer to 90, but 24.5 is not that close. So you're going to take, to get lower bound, you'll take sine 24.5. So now let's apply what I'm saying here. So the yz, it will be now equals. But what about the side length y? The side length y, which is xz. No, this is very easy. It doesn't need, you do this only when in case you have sine and cosine. So for the y is 16. So we need to get the upper bound to make this larger. So you're going to take 16.5 multiplied by, as I said, sine. Now I need to get the upper from this, the upper value from the sine of x. So the upper bound 135 or 125, no, you will take 125 to be closer to the 90. So the value of sine will be greater. So sine 125 all over sine. As I said, you need to get lower bound in the denominator, lower bound of an acute angle. So you get away from the 90. So it will be sine 24.5. Now you can get the YZ. Let's check on the calculator. We will remove the limits in here. Let's see on the calculator what's the value. It will be here. Let's remove this. 16.5 multiplied by sine. The angle is 125, and then close the bracket, all over sine 24.5, and then you close the bracket. It gives 32.59, and the answer, we need to find it to 1 dp, 1 decimal place, so it will be 32.6. This is the final answer for the side length, 32.6 centimeter. If you didn't know this one very well, so unfortunately you will solve this one incorrect, the question. But there is a shortcut, as I said at the beginning of the video here. What's the shortcut? If you don't understand this one very well, you can get the bounds as, what did we do? The bounds, like what we wrote here. For example, the x was between the 125 and 130, and the y was between 24.5 and 25.5. You can just do trial and error to check which sign gives the highest value. So you can try sine 125 and sorry, this is 135, not 130. You can do trial and error, the sine of 125 and sine 135. Sine 125, you need in the numerator to get the upper from the sine. So you check which one gives you greater value, sine either sine 125 or sine 135. So the one gives you a bigger value or larger value, just take it, like here. And then sine 24.5, sine 25.5. You need to get the lower bound from this. So you try both of them and check which one gives you a lower value if you don't understand the graph. This